Alright, so what is the least squares method? Well, let's assume that we have these four data points. We have grades and we have hours. So we have A, and I guess like a 3.5 would be here, and a B, and then a 2.5 would be here, and then, I'm sorry, 2.5 would be here, a 2, and then a 1.5, a 1, and then a 0 would be a fail. And then here we have the number of hours it takes. So I mean, 4 hours a night, I guess, would pretty much guarantee you an A, I'm sure. I might be wrong. I'm not sure how that works out nowadays, but let's assume this is the case, right? And so, what does the linear regression algorithm do? What it does is it starts with a line. It starts with any line, right? You might think like, no, it starts with the most perfect line, like right through there, right? Well, that's the end result, but that's not what it does. It starts with any line. Like it could start with a horizontal line. It could start with a line that looks like that, right? And so let's just assume that we start with this horizontal line right here. So what is the least squares method? It's a way for the linear regression algorithm to tell how good of a job it's doing, right? It's to calculate the error. And so what is the error if we have a horizontal line right here? Well, the error, let me use a pencil here because I'm probably going to make a mistake and have to redo this. So what the error is this distance, this distance, this distance, and this distance, right? And so let's call this 1, 2, 3, and 3. Okay. So what is the least squares method? Well, what it does is it takes this amount of error from the point to the model to the line that's like I guess a guess prediction to start out, and it squares all of them. So he says 2 squared plus 1 squared plus 3 squared plus 3 squared, and it adds them all up, and let's assume it's like 27. And that's the amount of error that we have. Okay. And so you might be asking yourself, like, well, why do you square? Right? What's up with that? Why do we do that? And so the reason for that is because once it finds the error, right, what the linear regression algorithm is going to do is it's going to adjust the slope and the y-intercept. So it's going to adjust the slope, maybe go this way a little bit, and then just the y-intercept move up a little bit. Right? And then it's going to recalculate the error using the least squares method. Okay? And it's going to find out, hey, it's lower, it's 21. Then it's going to adjust the slope a little bit, and then it's going to adjust the y-intercept a little bit. It's going to recalculate the least squares method, and it's going to find, hey, it's better, it's 18. And then it's going to adjust the slope a little bit. Maybe I can get to here, and then adjust the y-intercept and get to here, and it's going to find out, hey, it's better, it's 11, right? Okay, well, great. And then it's going to adjust the scope a little bit, and the slope a little bit, and then adjust the b a little bit, and it's going to move down, and it's going to say, hey, it's worse, it's not 11, it's 11.5. It's going to adjust a little bit, go up a little bit, and it's going to find out, hey, the error, what is it? It's 11.5 again. Well, that means the best or the line that minimizes the amount of error is this one right here with this slope and this y-intercept, and that is going to be my model. Okay, so that's how linear regression works. It tries one, makes an adjustment, calculates the amount of error using least squares, and it keeps on doing that, keeps making adjustments until it finds the one that minimizes the least squares method. Minimizes the amount of error. All right. So back to the question is why square, right? Well, when we're here, right, in this situation, let me see if I can write this like that. Let's say we're in this situation here. Well, this distance is not going to be 2 anymore. It's going to be 1, right? And then this distance here is not going to be 2 anymore, or I'm sorry, not going to be 1 right here, but it's going to be -1. All right. This distance here is going to be 1, and this distance here is going to be 0. Okay. So if we went ahead and added them, just didn't square them, and we just added them all up, then we would get 1, right? But then that would, I guess, eliminate these two amounts of error. And we want those amounts of error, right? Those should be valid. And so the way that is ensured is that you square it, right? Because then that gets rid of the negative sign. So you get 1 squared, -1, plus -1 squared, plus 1 squared, plus 0 squared. We calculate that all out. It's 1 plus 1 plus 1 plus 0, so that's 3, and that's the amount of error that we get. Okay, so least squares method is how linear regression calculates the error, and we square so that once we get to a place where there's a negative amount of error, then it's still evaluated when we sum up all of the errors.